Well, hello. My name is Paul, and we're going to be today talking about air handling. And I noticed that some of you have been working on your projects. I've gotten a few questions about things where you get an error. And today I want to talk about this because this is a good thing to be thinking about as you start writing the code and actually building the final version of your project, is how do you handle what are known as exceptions. So we're going to talk about that today. All right, so the first thing is you probably have noticed that when a Python program runs into an error, it stops. And this isn't just Python that does this. Other programs do this as well. Some programs crash, like you may have seen a program that you're running say, this program has generated an illegal operation, and Windows has decided to kill it or something like that. But that in Python, the Python interpreter, since it's an interpreted language, it has a special program called an interpreter that runs the program. If it detects an error, it stops the program from running and it displays an error message called a traceback. And I know that you've seen those before. If you've written any code, you've seen them. If you've watched any of the lecture videos, I've made mistakes and you've seen them. So here, for example, is what a traceback looks like. It'll say what line the thing was on, what file it was in, and it'll show you the line, and it'll say what the type of error was. Name error. Name capital B is not defined. So traceback is Python interpreter's response to an unhandled error or an exception. The interpreter says, hey, something bad happened, and you didn't catch it and do anything about it. You didn't handle it yourself in code. So I'm just going to print out this traceback and then stop the program from running because something has gone horribly wrong for me to get that error or that exception. Now, some exceptions are caused by incorrect programming, such as typos, like this one back here with a capital B instead of lowercase b, presumably. Some errors are caused by logic errors, or exceptions are caused by logic errors, like going off the end of a, let's say you put 3 things in a list and you try to access thing number 10 in that list that only has 3. That will clearly create an error. But other exceptions are caused by unforeseen circumstances, meaning there's nothing wrong with the way you wrote the code. The code might be fine, but the way the person used the code, they typed in a weird value, or the code needs to open a file in order for it to work, and somebody deleted that file, or somebody renamed the file, or something like that. And so if the former is the case, meaning that if it's a logic error or a typo or our bad programming, we should fix that as a programmer. But if the latter is the case, we can't really fix the code because the problem isn't in the code. The problem is something the code encounters when it's running that's an unexpected circumstance. So let's look at an example of what I'm talking about here with this type of error. So here's some example code. And the example code, it basically stops and asks the user to enter a value and then enter another value, and then it multiplies them. And then for them, after it does multiplication, it prints out a nice message saying, hey, this number times this other number equals this result. Now, when we execute that program, we type in 10, we type in 20, and it says type error can't multiply sequence by non-int of type str. And the reason we got that error is we made a programming error. We tried to take a string and multiply it by another string, and that just doesn't make any sense. Like, what is high times there? Doesn't make any sense. So in this case, it's a programming error. And the reason for that is we wanted them to have numbers here, but we just gave them the strings. So when they typed in 10 and 20, they tried to multiply the string 10 by the string 20, and that just didn't work. Because those are strings. We need to convert them to numbers. So this is a logic error. This is the kind of thing, as a programmer, we should fix. Now, to fix that, we add a little bit of conversion code here. So we put float around each of these. So we take the string and convert it to a floating point number, meaning a decimal number. And now when we execute it, we get this, 10 times 20, same input we had before. It doesn't crash this time. It says 10 times 20 equals, in this case, 200.0. So now everything seems good. It worked. It didn't crash that time. But there's still something more insidious here that we need to take a look at. So this, even though this seems good and it passed the test that this one before failed, there's still a problem that we're expecting the user to type something in. So in this case, it says enter a value, and they decide to type out 10, T-E-N, and then another value, 20. And now we get an error on the line where it's trying to convert that to a float. It's saying could not convert string to float. And then it tells us what that string is, 10. So the user has crashed the program by providing bad data. We asked them to type a number. They kind of did, but they did it as a word and not as an actual digits of a number. So the question is, what could we ever do about this? This isn't a problem with our program. It's a problem with what the user did and entered into the program when it asked them to enter something. So we don't want bad data to crash this program. How can we protect that? How can we protect it, the program, from somebody doing something stupid with it or doing something wrong with it? And that's kind of where exceptions come in. So we can't control the user. You can try to. You can give them a nice prompt. You could even tell them in the thing to type in, you could say, enter a number using digits only. But you can't make them do that. They could still type in some idiotic thing, or they could type in whatever and hit enter. So we need to come up with a better way of dealing with that. And it's not just the user. It could be the contents of a file that got edited or somebody corrupted them. It could be a drive fills up that you're trying to write to. It could be the internet goes down when you're trying to connect to something on the other end. It's just an unforeseen circumstance that the program encounters. It's not a problem with the coding. It's not a logic error. It's not a syntax error or a typo or something like that. It's something that the program in its normal course of operations would normally work, but something exceptional has happened, which is why we have exceptions. So the answer is we write our programs to handle the errors by writing error handling code. And that methodology is called exception handling. So what it's going to do, it's going to allow the programs that we write to do something other than just crash and stop. And that could be important. For example, if you have a program and somebody spent a whole bunch of time working on their entering things in, and they're 2 hours into some project and your program just crashes and takes a dump and loses all their work, you're going to have upset users. But if it handles the exception in a graceful way, and the program itself catches that error and says, hey, this drive is full, specify a different location, you're going to have much happier users. Now, you have to use it on the right kind of errors, though. All right, so here's a categorization of different types of errors for programming. There's syntax errors, and that's like using the language incorrectly. Like you forget to put a colon at the end of the line with an if statement, or you leave off a double quote, or you have a mismatched set of parentheses, or you use a single equal in a comparison where you meant to use a double equal or something like that. So that's a syntax error. Now, a logic error isn't really a syntax error. It's not something where we're using the language incorrectly. It's something where the idea of how we're solving a problem is wrong. For example, a logical error might be an off by one error. You try to go through everything in a list of 10, but you accidentally only go 1 through 8. Or you, opposite of that, you accidentally go 1 through 11. You go off the end of that array. That's a logic error, not a syntax error. And that's, as programmers, it's our job to ensure that we're using the language correctly, that there aren't errors in how we're using it. And it's also our job as programmers to ensure that our algorithms that we write don't have logical errors, that we're not doing the wrong comparison or doing a less than instead of a less than or equal to or something like that. But the third type of error here, exceptions, is when something bad happened when our program was running, meaning that something, an error condition happened that normally wouldn't, and that's usually caused by invalid input, meaning that that input could be from a user, could be from a file, or it's some sort of resource that should be available that's not there, a missing file, a drive that has filled up, a location on the internet where the internet has gone down, so something along those lines. Now, error handling can't do much about these two. It could maybe catch them, but you shouldn't use error handling to catch these. You should fix your code. But this one, since it's something that's outside of the scope of what our program can do, it's up to us to try to catch those if bad things could happen. Okay, so types of errors that we talked about. Our job as programmers is to fix the syntax errors and logical errors. But since we can't control what users input, we also can't control other exceptional things that could happen with files being missing or the internet going down or a device being unavailable, or somebody unplugs a device when it should be available and it's not anymore. It would be nice if we could write code into our program so that the program could deal with the exceptions by itself rather than just crashing. And the idea is to allow that program to gracefully handle those exceptions or errors rather than just stopping and losing all the work or completely crashing. All right, so exception handling is the way of dealing with that. So what an exception handling, how you deal with that is the things that you want to protect against exceptions happening, you indent inside of what's called this try block. And but anything indented under try colon, now the exception can be handled by this except block after that. So in other words, then you can have more than one line of code in here. You could say try to open this file, try to read the contents of the file, try to do these things. And if an error happens in here, it'll jump down to this except block and run whatever we have indented underneath that. So that construct allows us to wrap lines of code inside of one of these kind of protective wrappers. And if any exception happens while it's running that code, the except block of code gets jumped to and can handle that error. And it could just be something simple like printing out an error message saying exactly what happened, or it could be something like just skipping over and allowing them to change or fix something and then trying again later. But the important thing here is the program is no longer going to crash and stop. It's going to run this indented code whenever an error happens in these lines of code. Now, any unhandled exception gets passed upwards from wherever it occurred, and any exception that is unhandled by some try except handler anywhere in our code gets passed to Python's default exception handler, and that's when the traceback gets printed and the program gets stopped. So let's fix that problem we had in that code that we looked at earlier. So if you remember that code earlier, it looked like this. It said enter a value, enter another value, puts those into num1, 2, and then we do this multiplication of those two things. And then here, we printed out the result. But they could type in something that could not be converted to a float. So what we did is we still have them enter it the same way, but now we add this try except block. So here I try to do the multiplication and the conversion, and then I print the result. But if that fails to do this conversion, an exception is going to get thrown. And when that exception gets thrown or raised, sometimes it's called those exceptions are raised rather than thrown. But what happens is the except block then runs. So in this case, if they type in garbage, it's going to not crash the program. It's going to say you're evil, bad input, bad user. And if you wanted to, you could wrap that in a loop that then goes back and makes them try to re-enter this information again. And if you want to guard each value separately, you could do that as well. So that way they have to enter a good value for 1. They have to add a good value for value 2 in order to move on in the program. So in this case, notice the pattern, the design pattern of this code is I have a while true, and then it tries to get them to enter a value. It tries to convert that to a float. And if they failed for some reason, if this fails for some reason, if there's an exception that gets thrown, it jumps to the except block and it prints out error, not a valid number, type again. And then since this is in a while loop, it jumps back up and tries again, and it has them enter a value again. So the only way to get past this while true loop, this looks like an infinite loop, is to successfully enter a value that could be converted to a float. And then we hit this break, which breaks out of the loop. And now we're on to the second loop where we have them enter that. So this design pattern is a pattern you'll see sometimes in places where you have user input that's required. And we want to validate that user input. So we get the input, we validate it. If it's good, then we break out of the loop and move on. If it's not validated as good, it forces them to re-enter it. Oops, that's too far. And notice in this case, we don't need to guard the multiplication because we know we have two numbers when we get down there. Okay, you can also, in that try except block, rather than having it catch all exceptions, which is the default behavior that we had over here, you can also have it catch certain types of exceptions. You can say what kind of exception you want to catch. So in this case, we're saying true, have accept a value error. So we're only catching errors of type value error. If it's any other kind of error, it'll get passed upwards. If it's a value error, we'll catch it and handle it here. Now, that can be useful when there are different kinds of errors. There might be something more catastrophic that we don't want to say, try again if there's something else that's gone wrong. So in this case, we're only going to catch a value error because that's the kind that is if we try to use float on a value that doesn't make any sense, then we will get that value error. Now that can be useful for passing things along, like attempts to break out of the program using Control-C while still catching something like bad input. Okay, you can also specify groups of exception types you want to catch. So rather than just saying a certain type, you could make a list of them here, a tuple that has a list. So here I could say get a value error, get a type error. If it's either of those, we catch it. If it's not either of those, but it's still an exception that happened, pass it upwards. And you can really, if you want to, get that more fine, have a more fine-grained thing here where you say value error or type error and separate those with two except blocks indented underneath this try. So you can have a different reaction to one kind of error than you would have with another type. Okay, you can also add an else block to the end of the error handling. And what that does is that allows the code after the try block to run if there were no errors that got raised. So in other words, it'll try to run this code. If that succeeds and there are no exceptions raised, it'll run the else block. Now that's a little bit weird for people when you first see that, because you think, well, if this were an if, it would do this or it would do that, but it wouldn't ever do both. This is going to do both the indented stuff under the try. And here, because there's a break, it actually won't get down here. So this is probably a bad example. But the idea is that it'll do the stuff that's indented, and if that succeeds, it'll do the stuff in the else block as well. If it does this and it fails, and there's an exception that's handled by one of these, then these will take over and the else will not run. So that can be useful for having code that will only run if the exceptions were not raised and caught. If an exception was raised and caught, we will not do the stuff that's in the else clause. And one final piece of information here is you can actually have the Python interpreter give you a description of that error as well, which is like a string representation of that. So you could actually have it print that out. So in this case, if you say accept value error as error, ERR, this doesn't have to be ER, it could be as something else, but this variable here gets filled in with a string description of what that error was. And so you can print that out. So you could have an accept that then prints out what an error message that's appropriate for that error. So that can be useful for printing out appropriate messages or for creating a log file of what exceptions happened, at when and where in your code. That's something as you get to larger and larger projects you might want to add is start adding exception handling. And then when an error happens, one of the things I like to do is have in my exception handler something that opens a log file and sticks what the error was and what function it was in and what code it was in when that error happened. And a useful way to get that string that goes with the error, catch the description like we have here. Okay, now you might have noticed earlier on we talked about different kinds of error. We had value error, we had type error. So here's a list of some of the common exception types. Exception catches all, is a group that matches all of them. Runtime error is an error that doesn't fit into any of the other categories. Syntax error is something wrong with the code that you wrote. Mismatched parenthesis, missing end quote, something along those lines, missing colon in an if statement or a while, any indented thing after that. So those kinds of things. Single equal, where it should be a double equal. Type error means we tried to use the wrong type for something. A value error means it's the right type. but it had a bad value in it. And that notice that value error is why we got that thing with the string. That it was a string, which is the right type, but the value that was in the string was something that could not be converted to a float. Zero division error, that's just what it says. If you try to divide by 0 or mod by 0, you'll get a zero division error. Name error, IO error, index error, key error. Key errors happen if you use a dictionary and try to look something up that's not in the dictionary. Import error means that you tried to import something that maybe didn't exist, or there's a problem when it tried to import it. Module not found error, tried to load a module that can't be found. Keyboard interrupt, when the user presses Control-C to halt execution. Notice those are probably the common ones. I provided a link here for the list of all of the exceptions you might run into. So if you want to take a look at that, I would suggest looking through that. There is a way you can create your own exceptions and give them names and catch them as well. That's a little bit outside of what we're going to cover here today. But if you have a really complex API that you're creating, you can create your own types of errors that can be raised and then caught with the exception. So one thing to note, when you use try except blocks, where should you do that? Don't put them just gratuitously around all of your code and just catch errors like crazy, because you want to have logic errors and syntax errors show up so you can handle them by fixing the code. So the places where you need that, you also don't want to put them around code that really can't have errors happen, because it wastes time and it's extra things that the Python interpreter has to do. And if you're doing it for no reason, it's not providing any value, and it's providing visual, syntactical noise to look through when you're trying to debug a program. So where should you use it? Well, anything where an outside force could cause some sort of error to happen in your code. So the examples of that would be, you get input from a user. Ask them to input a number. Ask them to input, could even be some value, and they decide to put in the wrong kind of thing. So user input is definitely one. Also, anytime we're opening a file, or reading a file, or writing to a file, that would be a place for it. Anytime we're parsing file data, and we're, for example, expecting some string to exist after an equal sign on some line. If somebody edits the file and deletes parts of it out, it's going to crash. Or we're expecting the file to have 10 lines of high scores, and somebody deleted some of them and put a different file in its place. We could have an error when we're parsing that file data. Also, network I/O. Also, allocating large amounts of memory. It's possible that we could run out of memory that's allocatable for our project. So we should keep an eye out for exceptions like that. And also the keyboard interrupt. If you want to have it so they press Control-C to stop some server that's running or something like that, then that's another place where we should put exception handling. But error handling is not a remedy for syntax errors and logical errors. And I can't emphasize that enough. I've seen sloppy programmers that are like, yeah, I wrote really bad code, but I'm going to put a try except around this, so it'll all be good. I'll catch the errors. No, that's not going to fix anything. That's like having your car and saying, well, you know what, I'm not going to install brakes on my car because it's got airbags, so who cares? I'll just let it crash and the airbags will go off. You don't want that. You want to have something that's engineered and designed well, does what it's supposed to do, but then still has the airbags in case something unexpected happens. So use the try except blocks where it makes sense to use them, and only for things that are outside influence can cause errors to happen. Okay, well, I came in under a half hour to give you plenty of time to work on your projects. So go ahead and work on your projects. If you have questions that come up or things that you would like to have answered, let me know. Next week, we're going to dig into a few more special topics, things related to what you guys are doing for your project. I want to look at another type of rendering that's sort of like tile-based rendering, but it works a little bit differently. It's a method that I've used on some projects before, but it allows a little bit more flexibility for placing things in the world. It can be especially useful for kind of 2.5D semi-open world kind of things. It can also be useful for kind of side scroller, platformer kind of environments. But the difference between this and tile-based is it doesn't constrain you to have to put everything on a grid. You can have things that aren't really aligned to the grid that you still interact with. So we're going to look at that next week and a couple other things next week. I also want to look at another kind of animation for animating geometry and manipulating geometry using trigonometry functions. So we'll probably take a look at that next week as well. But anyway, work on your project. Stay safe. If you have questions, let me know, and I'll see you soon.